Welcome you all to a new session. This session is in continuous to the last class sessions of flip-flops. Here we are going to study about registers and as well as counters. So in this session we are going to see briefly about what are registers and types of registers and how they are going to function. We will see in detail about them. Now first of all, the definition for register. A register is a group of flip-flops that is used to store a word is called as a register. Now register means previously we have seen flip-flops and latches where they are going to store only one bit of information, but as a word or a set of statements that need to be stored onto a computer requires registers. As the definition itself, it is telling that it is going to store a word here. Now the word can be stored directly onto a register, or else we can control a reading operation as well as writing operation onto a register. Both the things I can explain here. Now you can see here this is the buffer register. This is a buffer register where you can see clearly that there are 4 letters which are coming onto my flip-flop. Now these 4 letters will be stored onto 4 flip-flops here. Now these are D flip-flops with a clock pulse which is present over here. Now this clock pulse is in synchronous with all the 4 flip-flops. Now the data is coming from terminals A, B, C and D. This 4 letter word will be stored onto these 4 flip-flops. Combining all these 4 flip-flops together, we call it as a register. Now after this, we are just storing the data and we are sending that 4 letter word as an output from this 4 flip-flops as 4-bit register. Now for example, if I are having a read and write operation to be performed, means when to read the information from the input terminal and when to give the information at the output terminal. Both the things are important for us now. Now at this particular point of time, now we are having a control signal which we are keeping at the input level as well as the output level. At the input level, we are having 2 things, loading and writing. Loading means we need to consume the data from the external world and keep that data onto the 4 flip-flops. Now whenever the data has to get readed, means whenever the data need to be given to the outside world, we are going to enable this read bar here. Now at the input level, we are having 2 things, loading and writing. Means we need to these terminals A, B, C, D will not be always on always, because this control signal is going to stop the reading of data from external world. Now this control signal is a tri-state device. Now it is having 3 terminals, that is input terminal, output terminal and a switch which is getting closed between the flip-flop and as well as the external world. Now this, whenever this is in active high position, what happens? This input A terminal, the data which is present at the input A terminal is going to get load onto this particular tri-state device. From there it is getting onto my flip-flops. Now from here the operation is normal compared to that of our previous buffer register. Here just we are controlling loading operation as well as reading operation. Loading means we are writing some data onto 4 flip-flops. After loading the data, when we are enabling our read signal high, then all these switches gets closed and the data from the flip-flops will be appearing as the output. So previous thing was buffer register, this is the controlled buffer register. Now let's see types of registers. Like we can shift data from right to left, from top to bottom, and we can also send the data serially from input to output. So there are shift of data that takes place under register. So these shift registers are of 4 types. Those are serial in, serial out register, serial in, parallel out register, parallel in, serial out register, parallel in, parallel out register. Now apart from these registers, we are also having one more register called as USR, that is universal shift register. Now we will see in detail about this CISO, CIPO, PSO, PISO and PIPO. Okay, the first one, serial in, serial out write shift register, means I am going to shift my data towards the right side serially. Means I need to consume data from left side and I need to release data from the right side. Now under CISO, the shift operation can take place either on right side or on the left side. Let's begin with the right operation. Now you can see this is a data in which is provided to my 4 D flip-flops here. Now from here what happens, whenever a serial data is appearing at this end, this first bit is getting onto my first flip-flop. Whenever my clock pulse is applied on my first clock pulse edge, first data bit is getting inside the first flip-flop. For the next clock pulse, what happens, the data in the first flip-flop will move on to the second flip-flop and a new bit gets entered into my first flip-flop. Similarly, the first bit has to come out through the last flip-flop whenever a clock edge is getting triggered here. Now let us see that operation using a binary values. Now you can see this is serial out and serial in we are getting. Now initially all the values of my 4 flip-flops will be 0, 0, 0. Now when at first clock pulse what happens, the first data enters onto my first flip-flop and remaining flip-flop values will be 0 only. For the second clock pulse what happens, this data is getting moved on to second flip-flop and a new data is appearing at my first flip-flop. Remaining 2 will be 0, 0. On the third clock pulse, my value on the second flip-flop will move on to third, first flip-flop will move on to the second flip-flop and a new value comes and exists on my first flip-flop. On fourth clock pulse, the third clock pulse input, the output will be appeared as an input for my fourth, second will be appeared on my third and first will be appeared on my second and a new data will appear on my fourth. Now as a clock pulse is applied, this data will move out of my register. So serially I am entering my data and serially I am getting my data output also. So this is how with the help of clock pulse we are going to move data from left to right side. So that is the reason we call it as a right shift serial in serial out shift register. Now same technique we are going to apply for our left shift also. Now but the direction changes. So on the right side we are going to apply as a input data, from left side we are going to take it as a output from here. Same 4 D flip-flops will be there here. This is as first flip-flop, this is second flip-flop, this is third flip-flop, this is fourth flip. And common clock pulse is provided for all the 4 flip-flops. Same from similarly here the data is applied. The same data, whatever the data which is moving towards this side will move now this side. That's the exact reverse operation of this thing. When the clock pulse is applied, the data will be shifted from one flip-flop to the other flip-flop. So this is called as serial in, serial out, left shift register. Next, serial in, parallel out shift register means serially I need to send the data into the flip-flop and parallelly I need to get the data out here. Now you can see here serial in, parallel out system is a core concept in digital electronics governing data transfer and processing. And the SIPO shift registers converts serial data to parallel data. Means serially I am sending as an input, parallelly I am accepting the data at the output level. That is the reason it is called as serial data to parallel data conversion. Now the key components are always the flip-flops here, and shift registers are wide application notably in digital communications. Now this is the block diagram of our serial in, parallel out shift register. You can see the 4 flip-flops are placed here like this, and every flip-flop is clocked here with the positive edge clock pulse and a serial input is applied here. Now serial input applied here, the output of first flip-flop is attached to the second flip-flop. First flip-flop output attached to second flip-flop, next second flip-flop output is attached to input of third and third output is attached to the fourth input here. So serially the data movement you can observe clearly here. Now to collect the data parallelly out, we are drawing the output lines from this serial input lines. 4 parallel lines has been drawn here. Now this serial input along with the clock is going to take 4 clock pulses to store 4 bit of information on my 4 flip-flops. Now when 4 clock pulses is appeared, my 4 flip-flops is having with 4 bit of information here. On the 5th clock pulse what happens, this data is going to get appeared as output here. So totally it requires 5 clock pulses to store data serially, and to get the data parallelly out only 1 clock cycle is required. Why? Because within 1 clock cycle I am able to get my 4 bit of information at a time, whereas to store the data it requires 4 clock pulses. So this is what here QA, QB, QC, QD, data in I am providing along with my clock. So each stage requires 1 clock pulse. So 4 stages are there. So it requires 4 clock pulses to store 4 bit of information. Now on 5th clock pulse, what happens? This data, whatever is stored under stage A, B, C, D, on 5th clock pulse, I am able to get that 4 bit of information as it is as the output here. So this is what we call it as serial in, parallel out, shift register. Now next one is parallel in, serial out, shift register. Parallel in, serial out, shift register. Means I need to perform parallelly inputting the data. Means it requires only 1 clock pulse to send the data onto 4 flip-flops, and it requires 4 clock pulse to get the data as a output here. Means here I am going to use a setup here where these gates in between my 4 flip-flops are going to act according to my serial input operation or parallel output operation, or parallel input operation and serial output. Now this you can see here, shift and load controller I am placing between the flip-flops. So I got 1, 2, 3 setups which are going to control whether to shift the data or to load the data. Now when shift/load bar is active high, means whenever this is high, what happens? The data at the input level, means shift is high, means this is going to act as a serial shift register. So whenever it is acting as a serial shift output register, the data which is coming onto my first flip-flop will go through this line and get onto this particular AND gate G4. Now from this line, whenever this is active, what happens? This line is also active. Now for AND gate, when 1 1 is provided as input, this is going to come as 1. Now for OR gate, if single in one input is 1, the output will be 1 here. So the data which is present here is coming as output here, and that data gets stored onto my second flip-flop. Now this data will shift to the next flip-flop whenever I am providing 1 more clock pulse. What happens? This data will go on to G5, that will come as output and come onto my flip-flop. So whenever my shift/load bar control signal is high, what happens? The gate number G4, G5, G6 are in active state. Means I am able to shift the data from one flip-flop to the other flip-flop serially towards the right side. Now when shift/load bar is active low, means I am making this signal as 0. So what happens? These particular signal gets enabled. So on the right hand side. So what happens? The connection which is made to these lines, the second AND gates, if you observe it, G1, G2, G3 will be in active position. So what happens? At that particular point of time, my input data, but the parallel input is getting activated. Means whatever the data which I am providing through the external links are getting onto my G1, G2, G3 gates, and that data will move into the outside, and that data gets stored onto my 3 flip-flops. So this is how we are going to perform parallel in operation and serial out operation using these particular setups between the flip-flops. Okay, we'll see the next shift register in the next section. Thank you.